Hello everyone, my name is Nicole and I'll be talking about my project, which is the Sustainable Food Production Prototypes. So through my foundation, I have seen many people affected by many disasters, such as floods in Venice, typhoons in the Philippines, wildfires in Australia, and hunger in Brazil. So I wanted to think of something to help benefit and solve these situations. So what is affecting us today? There is population migration, and my solution for it is to have a low cost and to be scalable. There's also pollution, and my solution for it is to have no emissions or runoffs. There's also climate change. My solution for it is to be carbon neutral and sustainable. And there's also world hunger. And my solution for it is to have food security and no wasting food. So here are my solutions. There's the aquaponics, and how this one works is that whenever the fish makes feces, waste, or as it's known, poop, it goes through a water pump all the way to the plants, and the plants filters the water and makes it clean, and the waste from the fish is actually nutrients for the plant and helps it grow. And the water goes back to the tank, and this all goes in a cycle. And how this is all powered is that it uses a solar generator and a solar panel, which makes it sustainable. So after a while, I've been realizing that the water has been evaporating, so I decided to make the water collector. And how this one works is that it uses a pelletized device which brings cold air going up and hot air going horizontally. And this uses condensation to get water from thin air. And how much water I got in one night was 165 milliliters. So I wanted to focus on the several phases of the plant. And in this case, the microgreens and the sprouting is more at the younger stage of the plant, and what I used here was radish and mung bean sprout. And I also wanted to focus on bigger plants, which as you can see here are broccoli, and this used a hydroponics. And how the hydroponic works is that it uses water and fertilizer mixed together, and it goes through a tube all the way to the plant, and the fertilizer goes back down to this bucket. And this all goes in a cycle because of a solar panel. So how do they all complement, or how do they all work together? So over here you can see that the sprouting and microgreens are mostly for smaller plants. Spores are like in the middle of smaller plants and medium. And aquaponics is more of medium plants, and the aeroponics and hydroponics are more for like bigger plants like broccoli or tomatoes. And as you can see in this column, the first column is talking about what energy they used and what the materials. And as you can see here, this is what the nutrients for the plants. And for the sprouting microgreens and spores, they used water. And in the third column, it talks about how this is automation friendly and how it helps with scalable, and it helps with to be easier and cheaper with monitoring, automation, and robotics. So some prototypes I'm thinking for this year is the aeroponics, which is growing plants with moist, and with growing from the spores, it's mostly mushrooms. And the honeybee farming is with bottles. And the objective of this is to make new farming technologies being sustainable, and to have monitoring, automation, and robotics. So I shared this project to several groups. There was Janalu Ortiz, who is from the Philippines, Katori Tubles, who is from the Lakota Indian Reservation in Alice, South Dakota. And there's also 2 other groups, but we're still in negotiation. And that's all I have. Thank you so much for listening, and thank you. Bye!